Hello Year 9, this is the Blue Book notes for today's lesson, sequences. I'd like you to pause the video and copy everything that you see. Okay, you may be given an nth term formula and asked to generate a sequence from it. So the formula at the top is given to you as part of the question. How you find the first term is by changing n to the number 1. So instead of the nth term, it's the 1th term, or the first term, and you find it by doing 1 squared plus 3, and that equals 4. For the second term, it's 2 squared plus 3, and that equals 7. And for the third term, we would be substituting 3 into the position that n takes in the formula. And if we do that, 3 squared is 9, plus 3 is 12. And the last example I'll give you is the 4th term. Now, I've written these out in full to show you exactly what's happening to the number 1, 2, and 3, and 4 as we put them into the equation. Now, when you're doing this in your work in your orange books, I'm happy for you to do that in your head. That's okay, but you must be careful, and you are allowed to write out your answer as a list of numbers or a sequence of numbers, and that list forms your answer. So that's the first skill I'm going to want us to be able to do today. Next on the agenda is finding that equation from the list of numbers, so going backwards from what we've just done. Okay, first thing we're going to look for, or the first thing we'll do, is you need to understand that there's only one kind of a formula you're going to find. Something times n plus or minus something else. So we've got two jobs to find the two missing numbers before and after n. So step 1, we're finding that first number. And the first thing we're going to do is find the common difference. That's the difference between the numbers as we go up through our sequence. So you often do this using arrows, from 7 to 10, from 10 to 13, from 13 to 16, from 16 to 19. We're adding on the same number each time, and that's 3. So the common difference is 3. And that 3, that first step, is the first thing you write down before n. So it's going to go right here, 3n. And then there's a number that comes after that. What we have to do is think about the term that comes before the first term. This is, of course, the 0th term. And it's up, over, and in front of 7. You can just figure it out. It's logically possible for you to figure out what number do you add 3 to get 7. Well, it's 7 minus 3, and that's the number 4. So the 0th term is 4, and it's a positive 4, so we're going to add it after, and instead of plus and minus, we're just using plus. So let's write that out again nice and neatly. Nth term equals 3n plus 4. Okay, this is just a change in how the question might look, so pause and copy down the table. It's the same idea. We're going to try and find the nth term, but this time we're not given a list going from left to right. It's going from top to bottom, and we're given n as just a column in our table. It's the same idea. What do you add to get to the next term? It's 5, so it's 5n. And what would come before 3? Well, that would be negative 2 in order to add 5 to that to make positive 3. So you just put minus 2 after 5n, and that is our formula. There's only 2 things going on each time, but you must get the 2 things in the right order. Okay, so for this particular problem, we're given patterns. So you're not given numbers, you're given a pattern, and you're asked to find the expression for the number of dots in any shape, with shape n, for example. So what we're going to do is write the values of n that we've got going down the column, 1, 2 and 3, and we're going to write down the excuse me, the number of dots next to each of those. So if we count up the first one, we're looking at 5 dots in the first pattern. So 5 goes into our dots column, 9 dots in this pattern, and 13 dots in our final pattern. So we tabulate our data, and we're ready to do exactly what we did on the previous example. We're adding 4 each time, and so it's going to be 4n. And the 0th term, the number before 5, would be the number 1. So 4n plus 1. So for any shape or any pattern number n, we can figure out how many dots we have.